Hello friends, let's learn difference between distance and displacement. You know, distance is the actual path length and displacement is the shortest distance between initial and final point. But some unique thing you should know, you are going to learn in this video lecture. So, first of all, we start from distance. Distance, as the definition of distance, it is the actual path length. This means that if you move from A to B, then normal from B to C, then again normal from C to D, and your movement is from A to B is 3 kilometer, from B to C is 6 kilometer, and from C to D is 5 kilometer. Then what is your distance? Then your distance is AB plus BC plus CD. So this is 3 plus 6 plus 5, which is here 14 kilometer. Now at the same time, if I discuss about displacement, just I have said displacement is the shortest distance between initial and final position. This means that displacement shortest distance between initial and final position. So if you have to find displacement here, then let us join this A and D point, join it. Then AD is displacement. So displacement is AD. What will be the value of AD here? For that, let us extend this B point and drop this C point. They meet at 90 degree at E. So this is a right triangle. In this right triangle, AD is equals to under root AE square plus DE square. This is Pythagoras theorem. Now, what is AE? AB is 3 kilometer and BE is 5 kilometers. So 3 plus 5 is 8 kilometer. This is 8 square. And what is DE? DE equals to CB. CB is 6 kilometer. So you have it is 6 square. This is 64. This is 36. Under root you have 100. Under root you have 10 kilometer. So this is displacement and this is distance. Let us understand this more with some another example. Suppose I am taking a number line. This is a number line. This is 0. Let this is 10. This is 20. This is 30 and so on. This side this will be minus 10, minus 20, minus 30 and so on. Let the margin. This is point O, P, Q, R. This side A, B, C. Suppose you start from point O and you move to point P. Then again you move from P to Q. And after that you take a sharp turn, backward turn, and you come to the point A. Then you move from A to B and from B to C. This means that you move from O to P, P to Q, then Q to P, P to O, O to A to B, B to C. This. Then what is the distance and what is the displacement? So when you talk about distance is equals to directly O to P, P to Q. That is this side. This is O to P is 10, OP plus PQ. Again you move the reverse. So you have QP plus PO plus you have OA plus you move to AB, so you have AB plus you move to BC, so you have BC. Note down here you are taking only the magnitude value. Magnitude means positive sign. So this is O to P is 10, P to Q is 10, and again Q to P is also 10, P to O is 10, so you have 10, 10, 10, 10, 10, 10, 10. 1, 2, 3, 4, 5, 6, 7. So you have 1, 2, 3, 4, 5, 6, 7. So it is 70 units. So distance is 70 units. But what about displacement? When you talk about displacement, then you have to take the sign also. So when you move from O to P, it will OP. When you move from P to Q, it will PQ. When you move from Q to P, it becomes minus QP. P to O, it becomes minus PO. O to A, it becomes minus OA. A to B, it becomes minus AB. And when B to C, it becomes minus BC. Now write the magnitude value. So you have 1, 2, 3, 4, 5, 6, 7. Again, you have 10 plus 10 minus 10 minus 10 minus 10 minus 10 minus 10. So you have 1, 2, 3, 4, 5, 6, 7. So you are seeing that this 10 will cancel. This 10 will be cancelled. So you have 10, 10, 10, 30. So minus 30 units. Thus, here you are seeing that distance is positive always. Displacement can be negative also. Now let us understand it with some another example. Let us take a circle. Here I am taking a circle. In this circle, this is the opposite signs, so they are diameters. We are starting from A, B, C, D. Let us have a point here P. So you start from B, you start from B, and you move to point P. So what will be the distance and displacement covered? For that you have to join this O and P. The angle is here theta. So your distance is arc length BP, which is written as BP arc. You know that from O to B is radius r, and this is equal to this line. So O to P is also radius r. You know that theta is equals to BP arc upon radius. So this is BP arc upon capital R. So this means that BP arc equals to theta into R. This is the distance. But you talk about displacement. Then for that you have to join this P and B with a straight line. Join it. So displacement is equals to BP. How we obtain BP? To obtain BP, let us take the bisector of the angle theta. This is the bisector of the angle theta. It meet on the opposite side BP at 90 degree. Let this point is E. So from BE is equals to X. Let it be X, and this angle is theta upon 2. So you have a right triangle. In right triangle, this is the triangle is BOE. You have sine theta upon 2 is equals to perpendicular by hypotenuse. So perpendicular is BE. BE is perpendicular and hypotenuse is OB. as BE is supposed to be x and OB is r, so you have x is equals to r sine theta upon 2. Now you required BP, so BP equals to 2x. This means that 2 into r sine theta upon 2. So BP is equals to 2r sine theta upon 2. This is the displacement. So thus you have learned how to find distance and displacement here. Let us have another example on the same diagram. Now in this example, you have to move from point B to D. So distance and displacement for path BCD you have to find. So number A, when you find distance, then distance is equals to actual path length, so it is BCD arc length. So you know that the circumference is 2 pi r. So 2 pi r is the circumference, so you divide by 2 is pi r. So this will be pi r. This can be found by the formula just we have generated. What was the formula? Also we have distance is equals to theta into r. So theta is 180 degree. 180 degree is equals to pi radian. So you have pi r. If you have confusion or if you have you want to enhance your concept on degree and radian, then see my video lecture of degree and radian, which will be on link will be provided on the description box. Now here, so you have find distance, and if you have to find displacement, then displacement is BOOD. Displacement is BD. This means that this is BO plus OD. So R plus R, which is equals to 2R. Thus you have learned that distance and displacement, that distance is always a positive quantity, but displacement can be 0, negative and positive. Distance is a scalar quantity and displacement is a vector quantity. Distance depends on path, displacement does not depend on path. These points should be written for difference between distance and displacement. So if you want to distinguish between distance and displacement, this can be done as distance. This is the actual path length. So it is the actual path length. Displacement, it is the shortest distance between initial and final point or position. Now next, distance, it will always be positive. So distance, it is always positive. Displacement, it may be positive, negative or 0. It may be positive, negative or 0. Distance is a scalar quantity. Displacement is a vector quantity. So you have seen that distance is path dependent quantity. Distance is path dependent and displacement is path independent. So displacement is path independent. Now one more important difference is that when you talk about distance, distance is greater than equals to displacement. So you write that displacement is less than equals to distance. These are the difference between distance and displacement. You have learned what is the difference between distance and displacement. You are enjoying physics. Do like, subscribe and share my channel. Physics Gold Ravi Kumar. Thank you.